Hello and welcome to EE 233. I'm your instructor, Gregory Myers. In this video, we're going to take another look at our P3, in this case, a sample P3 that focuses on some physics formulas. This video assumes a couple of things. Number one, that you have completed your P2, but also that you've completed your P3 and that you're effectively ready to test it. In other words, that you've got all of your switches set up correctly, all of your functions working correctly. And now what we're going to do is we're going to focus on automating the testing. Now, technically, this video could have been completed before you wrote your functions. It's just that in this case, we're already going to have output. So effectively, you can reverse the order of this process and do your batch testing after you have all of your switches set up and that you have your functions stubbed in. Effectively, what this means is that you can really reinforce this top-down design and combine it with testing so that you can automate the whole procedure as you're going along. Don't worry if that seems like a lot, it'll make sense to you with some practice. Now, you'll want to go ahead and grab a copy of your P3 instructions, and you'll note here that I have some rather obscure or rather oddly named text files that I'd like for you to provide. And these names are kind of a little bit arbitrary, but also, I guess you could say a little bit ornery. In other words, they're a little challenging to keep up with. But the idea here is I want to build a case to test my 1D version of my P3. I want to have another case to test it, and so on for the 2D and for the beam. And the idea is that you would build multiple text files to be able to pass input arguments to your scanf and your function ultimately. Now, we're not going to focus on the parametric switches in this video. I'll say something very briefly about it at the end, but what you want to do is you want to begin this by going to your executable directory, making sure that you have file name extensions checked, because otherwise this is going to get very confusing. And you simply want to create text files with each one of these file names. And we're going to go ahead and do all of them at once, just so we can get this part out of the way. So you right click, you create new text file, and then you very carefully follow my format. And so in this case, it's going to be P3 underscore 1D underscore case 01.txt, P3 underscore 1D underscore case 02.txt, and so on. As a matter of fact, you could probably get away with a little bit of copying and pasting here if you're careful. So there's our P3 2D case underscore P3 underscore 2D underscore case 01. I'm going to go ahead and copy and paste this, create new text document, and then change the 1 to 2. And then alternatively, what you can do is you can come over here and just simply borrow the name out of my instructions. And there is our beam case 01 and our beam case 02. Now, as of right now, all of these files are empty, and you can notice here that they're all 0K. And then if you drag them into NetBeans, either one at a time or all, you'll see there is nothing in them. What we want to do is we want to populate each of these case files with the inputs that we would otherwise be providing from the command line. So let me give you an example here. We'll go back to our executable. So there's our p3.exe. We're going to do 1D, and we're going to do it interactive. And we are prompted for the height, in this case, 100. And we get our nice table. What we can do instead is we can put that value in a text file, make sure to save it. And then we can come back over to the command line. And instead of working with your application interactively, we can simply pipe the contents of that P3 1D case 01 text file directly into your executable. In other words, when there's a scanf, it's going to get the data from the text file as opposed to getting it from the user. And so you'll see here that we're essentially passing the same value to our function, and ultimately we can see it here in the table. The difference is, while we were still prompted to enter a height, we didn't have to do so from the command line to get that value from the file. What we can do now is we can now have a different value in our P3 1D case 2 to see how it works. So we'll put in 200. We'll save it. We'll go back here to the command line and we'll simply change the file that we're using to get the input from to our case 02. And you'll see that sure enough, now all of my calculations are based off of 200. Well, we can continue this for all of our text files. And so at this point, you can go ahead and pull in both of your P3 2D cases. And for the 2D case on 01, remember that you have to provide two pieces of information, the VINIT, and then also the theta. And we'll go ahead and do the same now for the case 02. Provide a different piece of information, let's say 200, and then something like maybe 0.3233, which is simply an approximation of pi over 6. .5233. Sorry, it took just a second. That didn't look right. All right, so there we go. So we have a 200 and then 0.5233. And then you come back over here to the command line. And what we'll do now is we will test our /2d/I, and we'll pass to it the P3 2D case 01.txt. And we don't have to essentially answer these scanfs interactively. Instead, every time there's a scanf, it just simply pulls from the file. And you can see here that there is our VINIT and there is our theta. We can also do the same thing with our case 02.txt, and you'll see there's our 200 and our 0.5233. Last set that we want to look at will be our beams. And remember, in this case, we have three pieces of information. There was the load, the length of the beam, and then the location where the load resides on the beam. And so we'll do two different scenarios here. We'll have a 100-pound load, 10-foot beam, and then we'll move the load closer to one end for an A of 1. And then you can come back over to the command line. We'll do /beam/interactive, and we'll pass to it our P3 beam case 01.txt. And you'll see the same results that we saw in our earlier videos, where 100-pound load, length of 10, and an A of 5 results in two reaction forces that are equal. And then if we switch over to our case 02, you'll see that the load essentially has shifted to one end of the beam, and therefore R1 is larger than R2. Now, at this point, we have all of our text files set up. And if anything, what you want to do is go back to the instructions to see what else you need to provide. You'll see that I'm asking for a batch file. Well, To understand what a batch file is, we're going to go back to the command line and we're going to take a look one more time at all of our examples here, starting back with our P3 1D/1. And when we were piping the 1D case01.txt to it. Well, when we do this, we simply put the output on the command line. Well, there's an additional step that we could do in that we can capture the output using the pipe out or the greater than sign, which will allow for us to then write what would otherwise come to the console instead to a file. And this is useful not only for your executables, for other applications that use the command line as well. And in this case, what we're going to do is we're going to output all of this to a file that we're going to call p3.out. Now, don't focus too much on the file extension. It could be a .txt, it could be a .out. For that matter, it could be any file extension that you want to use. In this case, I'm just going to emphasize that it's our output file. And you'll see now, if you go back to your directory, that in addition to the .txt files, we also have a p3.out, and everything that was otherwise on the command line is now in the text file. And if you'll notice, nothing was outputted to the command line. Now we can repeat this for each one of our cases, but you'll note here that when you do case 02 and pipe the output to p3.out, that the output file gets overwritten. In other words, what was earlier 100 is now 200. To accommodate that, what we can do is we will rerun our case01.txt and we'll pipe the results to our p3.out. But then when we rerun our case 02, what we'll do is we will append to our p3.out or add to the bottom of our p3.out the results of our second run. And so you'll see now that in NetBeans, our p3.out has additional information. One, the first case was run, and then the second case followed it. In other words, it wasn't overwritten this time. And hopefully at this point, you can quickly see that we can do this for all of our cases. And so with a little bit of care, we'll come in and we'll simply convert this to 2D interactive, 2D and case 01, and we will append that to the output file. And you can see here that I'm slowly accumulating output. Do 2D case 02, and then we'll do it for our beam. And then the second case for our beam. At this point, what's happened is we have essentially aggregated the results from all 6 of our tests. Now, how can we take this one step further? Well, it turns out that everything we do on the command line can be put into a batch file, and that batch file gets run. And so the idea is that essentially, instead of having to do all of this manually from the command line multiple times, you can simply put all of the commands that you would otherwise do on the command line into another file, in this case, a batch file, and you can simply run the batch file every time you want to test your code. And so we'll start off, we will create a new text file that we are going to change the file extension to. We're going to call this p3.bat. You're going to be warned about changing the file extension. You want to select yes. This is once again why it's necessary for you to have your file extensions turned on. We're going to drag this and drop this into NetBeans. You can also right click and edit, but it's easier just to do this in NetBeans. You'll go back to your console, and then you can very carefully go through and copy each one of these line by line into your batch file. So it'll take just a second to do this. I'm going to bounce back and forth between the console and NetBeans. We're going to capture our P3. And you can do this manually if you want to. P3 2D. For both of the cases. And hopefully you start to see the pattern here. Basically, everything that we were doing earlier on the command line can now be done in a batch file. And I'm going to do this last one manually just so that you can see that you can just go through and edit this batch file, much like you can any other text file. At this point, we're going to save this. You want to go back to your MinGW folder and very carefully delete your p3.out. Do not delete your text files because at that point, then you'll be losing work, but delete that p3.out. And then I want you to come back to your command window. Go ahead and type in clear or CLS rather, a little too much MATLAB there. Let's do clear screen, CLS. And at this point, what we want to do is run p3.bat. And essentially what happens is it goes through and it runs each one of the commands that you have in your batch file, but also more importantly, there is your p3.out again, and it has all of your tests in one location, or rather the output of all of your tests in one location. Now, for the purposes of the P3 as it's described in these series of videos, you can stop. I do want to take just a second and point out that you can actually do this for your parametric commands as well, and for testing your help. And so to see what I'm talking about here, I'm going to go back to my batch file, and I'm going to go ahead and do another series of commands, our p3.exe 1d/p, and I will provide it the input argument, and I'm simply going to pipe this or append it to the p3.out. And we can do the same thing for our 2D parametric using 100 and then 0.7854 and p3.out. Likewise for the beam/beam/parametric. And remember that that requires 3 pieces of information. And we once again append that to p3.out. And the cool thing about it is you aren't limited to your interactive and your parametric. You can also test things like your help. And so, for instance, if you want to check to make sure your help is working, you can simply pipe the output of that to p3.out. And for that matter, if you want to check to make sure that the default, in other words, no switches, is also pulling up the help, you simply make a call to your p3.exe. Pretty much everything that you can otherwise test from the command line can be done in a batch file. And so if you come back here one more time to the command line, clear the screen, we run our p3.bat, we've made it a little bit longer, and as you can imagine, your output is now also a little bit longer, including 2 calls to help and testing your parametric options as well. So this is not limited solely to testing your interactive features. So it's a really good habit to get into, to write a batch file before you even start writing your code, just so that you can go ahead and get an idea of what types of options that you want to test. So I'm going to go ahead and stop this video here. As always, if you have any questions, comments, or concerns, don't hesitate to email me, and thank you for watching.